Hey there, I'm going to show you how we're going to connect the OpenCM904 controller with the expansion board to this Robotis Arm using Dynamaxel servos, and we'll control the whole thing using ARC from Synthiam. On our desktop, we want to visit Synthiam.com, and we're going to click on Products, ARC. I like to use the ARC Beta because it gives you the latest versions. So you can download ARC Beta and install it. And once it's installed, scroll down further, and you can locate all the different hardware products that are compatible with ARC, and locate the OpenCM904, and click on it. And you'll see here that you can download the firmware. We're going to click on Firmware Setup Instructions. And there's a walkthrough on how to install the libraries into the Arduino IDE to program the OpenCM. Once you follow these instructions to install the Robotis Arduino IDE tools, click Download Latest Version of the firmware and locate the file, uncompress it, and go into the folder. And if you already have the Arduino IDE set up by following those previous instructions, you should be able to double click on the INO file and load it right into the Arduino editor. Here you'll notice that there's 2 bits of information. If you're using the Robotis servos plugged into the OpenCM, the top board itself, and any of these ports here, then you're going to want to be able to use UART 0 in the ARC software. So any of the ports on here. If you're using the expansion board, these ports, you're going to want to be able to use the UART number 2. And you'll see what that means in a minute. So let's first program the firmware onto the OpenCM board. And plug the other USB cable into your computer. And on your desktop, go under Tools, and you should see the port selected. And then under Board, select the OpenCM904, which I already have selected here. This will appear when you install the Robotis IDE tools. Then click on the Upload button and sit back and wait for the firmware to be compiled and uploaded to the OpenCM904. If you see a message that it's been done uploading, we can close down the Arduino IDE, close down the web page, and let's load ARC. So before we get started with setting up anything in ARC, let's set up the OpenCM to connect to the robot arm and give it some power. So I'll plug the servos into the OpenCM board. Doesn't matter what port, as long as it's any of those, because they're all hooked together. And then we want to give the controller power, so we're using an adjustable power supply, which I have set for 11.1 volts. And we'll just plug into the barrel jack. And you can see there's a little bit of current draw from the servos, but they're not actually being used just yet. In ARC, we're going to add the robot skill for the Dynamaxel servos. So we'll click Add, locate the servo tab, find the Dynamaxel control, and you'll see here that it's grayed out because it's not installed yet, and click on the little download icon, and it'll download it from the repository and install it. And here it is here. So to begin using it, we first want to connect our software to the OpenCM. So you can see here that it's detected COM6. We'll push the connect button. And you can see at the bottom down here that it's connected to the OpenCM device. We'll click into the configuration of the Dynamaxel. Select port number 2, because we're going to be using the expansion board for the OpenCM. The baud rate of 1 megabit is what we're currently using for these servos. That's what they're configured for. And under the Utilities tab, we can click Scan and Find All Servos. So you can see here that discovered some XL or XM430s at ID 1, 2, 3, 4, all the way up to 5. So back on the Settings tab, we want to configure 1, 2, 3, 4, and 5 to be using the XL430 And then we can click Save. Now we want to create some animations for the robot so we can make it move. So we'll click on the Add Robot Skills. Under Servo tab, select Auto Position. This auto position can also be used to make robot gaits for different motions and movements. In this case, we're going to make the robot run a very specific predefined routine. Click on the three little dots to edit the auto position. The frames will be located here, so we're going to start with a new frame, and we're going to click Add a Servo. Now we're going to move the servos around to replicate what this robot arm looks like. So I'm going to put this down at the bottom. This will be the base, which is ID number 1. Now when I click Close, this robot arm is going to move into the 90-degree position in this servo here. And if we don't want the robot to move, then we can uncheck the real-time update here, and none of the servos will move while we're editing them. But I actually want to see them move, so I'm going to keep that checked. We'll click and add another servo. We'll put this one above it. This one is going to be virtual port number 2. We'll make another servo above that, number 3. And another one. We'll put it off to the side, which is going to be number 4. And then finally we want the gripper, which I'm guessing is going to be on number 5. There we go. So now we're going to make an animation where the robot will pick up an object, say this little white distance sensor, and move it around. So we'll click a new frame, and we'll call this Pickup Demo 1, and hit Enter. Now we want to move the robot into the position to pick something up as frame number 1. So we're going to uncheck Port Edit Mode so we can just see the servo positions. And let's move these servos into that position. We'll open up its gripper wide enough to be able to take this object into it. There we go. And you can move the robot as well by hand to reverse kinetics to be able to actually position this robot. We'll show that to you in a minute. So now we're going to create new frame, and it's automatically going to call this frame number 2. And now we want to close the gripper on the object. There we go. That feels nice. It feels like it's not too tug and putting too much pressure on the servos. Now we'll click New Frame, frame number 3. In this particular frame, what we're going to do is we're going to actually move the robot by hand. So what I'll do is I'm going to click Release All Servos, and then I'm going to move the robot by hand. And I'm going to place it up like this, and then I'm going to push this button, Get All Servo Positions. And now all the servo positions have been retrieved, and we can move the robot into that position. There it is. And then we can make another frame from here, from this frame. And you can see here that I can rotate, again, move the servos around, but I can also right-click in here and type in a number. So like 120, which is the number of degrees we want the robot to move. So now we can play back our frames one by one. 3, 2, 1. And we can link these frames together into what's called an action. So we'll click on Actions, make a new action called Pickup Demo, and we'll add 1, 2, 3, 4, and then 3, 2, 1. So it's going to repeat back and forth that exact same configuration. So we can execute this now, and you're going to see how it's going to run using the default settings. So it ran one time, and it ran real quick and put that object down really fast. So this is a really good learning experience, because watch what happens when I click on repeat this action. You're going to see how fast it's going to move. So we'll click stop, Now we're going to want to add a couple different pauses while the robot is actually moving so that we can prevent it from placing it down super hard and moving really quick. So there's a pause command here which we can add. We can move up pause. We're going to place it underneath number 1. And we're going to right click on the milliseconds to pause. We're going to pause for a full second. We'll add another pause command. We'll put this under number 2. And we'll pause for a full second. We can right click on number 2 and you can see in transition to frame and see which frame we're actually referring to. Okay, so we can test those out. And then under number 2 here, we'll do the same thing. Edit frame details, 1000 milliseconds, and we'll do it again here. So this is going to allow the robot to give it a little bit of time to settle down physically from moving before trying to open and close. So let's run this script now and see what it looks like. So very simple script, and we can close this down. And now what we want to do is we can trigger this script using different methods. We can trigger it using our voice, or we can even add a camera to this robot. Unfortunately, I don't have a camera that I can use because they're all being used to record this video. So you'll have to look at some other tutorial videos on how to add a camera to the robot and have it track the objects. But in this case, we can use speech recognition and have this robot execute these commands using speech. So I'm going to click Add on Robot Skills, Audio, and choose Speech Recognition. When this skill has been added, you can configure it. And we're going to add a new robot phrase that is Robot Execute Demo. And then we're going to click onto the script that's going to run. We're going to click on the JavaScript tab because that's the code we're going to use. And I'm going to right click into the editor, and this is going to interrogate all the robot controls and skills that are currently added to the project and ask them what they can do. So you'll notice that there's different functions that each skill says it can do. For example, in the Dynamixel, you can enable torque and turn on LEDs, but in the auto position, we just want to run the pickup demo. And now we also want to have the robot speak and say, I am running the demo. And we'll save this. Now we want to be able to stop the robot because it's going to be in a constant loop. So we're going to use the robot stop phrase that's already here. And we're going to edit the code for that. Remove the code that's in there because that's for movements. And in this case, we're going to use the cheat sheet, locate in the auto position list, find auto position stop and select it. And we're going to do the same thing, audio.say, and have the robot speak and say, I am stopping the demo. So now we can speak to the robot and say, now if you want to know what commands you've added to the speech recognition system, you can click on this button and see the list here. Robot, execute demo.
I am running the demo.
Robot, stop demo.
I am stopping the demo.
You'll see the commands that were understood in the speech recognition here, and as well, all the frames that are getting executed will display in the auto positioner. You can explore different skills to be able to make the robot do different things, such as be remote controlled by joysticks, or be remote controlled by your phone, or even over the internet, using different skills that exist. So for example, for joysticks, miscellaneous tab, there's a variety of different ones here, including the Wii controller. And to use the camera, for having the robot understand objects and track those, you can use the camera device. Under camera device, you can configure that to be able to move servos using servo tracking. In this case, you would select your virtual servo ports and add those to be able to control the robot based upon objects on the screen. So we can get into more details about those at a later time, But I hope you have fun with what I've demonstrated today, and looking forward to see what you guys come up with.